Hello friends, so today we'll discuss about uh, component critical pressure and operating temperature of column. So you know this fractionation distillation column you represent like this. So this and like this. This is D, we represent top portion, and this is bottom B. This is feed F. This will represent XF. This XD. This is XB. Okay, so this is the representation of a column. This number of plates. So the critical thing is how to fix the temperature of column for better separation and applicability of Raoult's law. So for calculating the operating pressure of column, so we know that this is the equation yi is Raoult's law, P equal to xi pi set. So this yi equal to xi into pi set upon p. This p is the operating pressure of column, and this yi is the vapor fraction of component I which you want to recover. Let's say in top product this is yi here, this is xi here. So it depends how much you want to recover. Let's say you want to get it 80% in this I component in top of the column, so you can put it 0.8, and so in liquid it will be around 0.2, because in vapor fraction you are recovering 80% of the I column. So this, if you know the value of pi set, so you can calculate the column operating pressure. This pi set, it can be calculated using Antonio equation. So what is Antonio equation? This is ln P set equal to A minus B upon T plus C. So here this A, B and C are the component specific constant which you can get from the data book. We have even in Perry also it's there for pure components. And T is the temperature. So at the whatever is the temperature you take, so you will get the P set of that component. Let's say if it's a mixture of alcohol plus benzene, and you say this is I component, you want to recover alcohol, so you will get the A, B, C value for alcohol from a data book, and based on your temperature you will get the pressure, saturation pressure. That pressure you can put it here and you will get the operating pressure of the column. So this way you can calculate the pressure. But the main thing is column temperature, this one, because here you what temperature you should keep. So how to get the column operating temperature? See, actually, for getting the operating temperature, we should know that the component which you want to recover, let's say you want to recover alcohol from alcohol benzene mixture. So you should know the critical pressure of this, critical temperature and critical pressure of this component. Because to get the proper separation and the applicability of Raoult's law for separation, the critical temperature and the temperature of this column, see this, the temperature of this column is T. In entire column, this temperature of column, let's say here it's T1, here it's T2, here it's T3. So the average temperature also, the T average also, or any temperature T1, T2, T3, it should not be more than the critical temperature of alcohol or the component which we want to recover. Because if if the column operating temperature is more than the critical temperature of the component which we want to recover on top, then during the in revoiler when we are vaporizing it and the temperature is above the critical temperature of recovery component like alcohol, then it will not change the phase and it will not separate out, and the applicability of Raoult's law will finish. Because Raoult's law is not applicable for those component whose critical pressure critical temperature is less than the system operating temperature. So if the Raoult's law is not applicable in a column, so there will not be any separation. So you have to keep in mind that the temperature, operating temperature of the column should be selected in such a way that it should know, and the duty of revolver should be selected in kept in such a way that the temperature of the column at any point of time should not go beyond the critical temperature of recovery component. So that's the reason, and if that we should keep the temperature of a column below critical temperature of recovery component. So this is all about critical temperature and column operating pressure. Thank you very much. If you have any doubts, write me in comment section. I will give you answer. Thanks a lot. Bye bye.